Alright, let's try adding binary numbers. So adding binary. Adding binary numbers is fairly easy because you just have to remember 8 rules. Technically, just 4 rules, but I'll show you why sometimes you need to take into account 8 rules. So the rules are, if you have a 0 plus 0, then this is a 0. If you have either a 1 plus 0 or a 0 plus 1, you get a 1. If you have a 1 plus 1, you get a 0 carry 1. So these are the rules that you follow if there is or if there's no carryover. If we don't have any carryovers, these are the rules that you follow. However, if you do have carryovers, then you follow different rules. For example, 0 plus 0 with a carryover, you have to account for the carryover, so this becomes 1. If you have either a 1 plus 0 or a 0 plus 1 with a carryover, then you have to account for this. It's as if you're adding 1 plus 1 again. So we know from the first rule that that's 0 carry 1. This is also the same, 0 carry 1. If you have a 1 plus 1 with a carryover of 1, it's 1 with a carryover of 1. These are the rules that you follow if you have a carryover. Alright, let's see it in action. For example, we have x. For example, we have 101, 101. This is the binary representation of 5. And we have 111, which is the binary representation of 7. We're expecting a binary representation of 12 as the answer to this. Let's add the two binary expressions that we have here. So if we have 1 plus 1 without a carry, we know that we will be using this rule. So it's a 0 carry 1. 1 plus 1, or 0 plus 1, 0 plus 1 with a carry, 0 plus 1 with a carry, it's 0 raised to 1. If we have a 1 plus 1, carry 1, 1 plus 1, carry 1, then we have a 1, carry 1. And then since there are no more numbers left, we can just copy this here and we end up with a final answer of 1100. If we use the same technique we used before, where we're multiplying each of the bits to powers of 2 and then adding them up, we know that these zeros don't matter anymore. Let's just add these two digits. We have 2 times 2 is 4. We have 2 times 2 times 2 is 8. 8 plus 4, we get 12. So that's how you add numbers. Now subtraction in binary has an extra step. So for example, we are trying to subtract 3 from 7. So we have 7 again. Let's use the 111 representation again. That's my 7. And let's have a 3 here. 0, 0, 1, 1. That's a 3. We anticipate that we will be getting an answer of 4, the binary representation of 4. In order to subtract two binary numbers, we first need to do something with this, the number that you're subtracting to the given. What we need to do exactly is to get the 2's complement of 3, and you do that by flipping the bits. Flipping means just getting the converse value of whatever bit is given. So the reverse of 0 in the binary system is 1. The reverse of 1 is 0. You're just simply flipping. If it's a 0, it becomes a 1. If it's a 1, it becomes 0. And then after flipping, you just add 1 to the flip value. Whatever you get after this step is your 2's complement. So 0 plus 1 is 1. As per the rule, 0 plus 1 without a carry, 1. 0 with nothing to add to it is just 0, and this is just 1. Take note that this is now the 2's complement of 3, making it a value equivalent to -3. in the world of 2's complements, check out the slides for the detailed explanation for this, but this is not equal to 5. This is not 5. This is negative 3 in the 2's complements as per the process we just did. Now that we have the 2's complement, we can now process these two numbers. So 111 and 101, we can now add them. If you add the 2's complement to the, or sorry, subtracting simply means getting the 2's complement of the number you want to subtract to a given number and then adding them up. So we are now at the step where we got the 2's complement. Let's try adding them up using the rules of addition we just discussed. So 1 plus 1 is 0, carry 1. 1 plus 0 with a carry is still 0, carry 1. 1 plus 1 with a carry of 1. 1 plus 1 with a carry of 1 is 1, carry 1, and we just copy this one here. However, since we're subtracting 3 digits, the last one is already an overflow, so we just ignore this. Again, for detailed explanations, just go to the slides, but the purpose of this video is to just show you the steps so that you get familiar with them. If we try to again convert this to our decimal, so 2 raised to 2, we arrive at 4, which is the number that we wanted. 7 minus 3 is indeed equal to 4. So there you go. That's how you add and subtract binary numbers. Thank you for watching. I'll see you in the next video where we will be discussing how to represent floating points in binary in both 16-bit and 32-bit systems. Thank you for watching. Goodbye.